This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the fundamental theorem of calculus. So what is the fundamental theorem of calculus? It is a tool that enables us to evaluate definite integrals, which of course represent the area under the curve. So if I have the integral from a to b of some function f of x dx, I can evaluate that by just finding some other function, capital F, evaluate at the endpoints b and a, and subtract. So this is a remarkably powerful formula for us to use. But what is capital F? Well, capital F is a function whose derivative is little f. So if I have this function little f, I've got to think of a function capital F whose derivative is that little f. We call capital F the antiderivative of little f. And the way that we typically write this, the notation we prefer to use is we say the integral from a to b of f of x dx is capital F the antiderivative evaluated from the endpoint from a to b. This of course means f of b minus f of a, but this is the notation we'll be using. So if we look at the integral from 1 to 3 of x squared plus 5x plus 1, using the fundamental theorem of calculus, I need to find an antiderivative of that. What's an antiderivative of x squared plus 5x plus 1? How are we going to do this? Well, the antiderivative of x squared is just x cubed over 3. Antiderivative of 5x is 5x squared over 2. Antiderivative of 1, tell me a function whose derivative is 1. The answer is x. And now we're going to evaluate this from 1 to 3. So that's one way for us to do this. We're going to plug 3 into this capital F function. We're going to plug 1 into that capital F function and subtract. You'll notice 3 replaces x, 3 cubed over 3, plus 5 times 3 squared over 2 plus 3. That's plugging this number, the top number, in for x, and then plugging 1 in for x, 1 cubed over 3, plus 5 times 1 squared over 2 plus 1. Simplifying this, 27 over 3 is of course 9, 3 squared is 9 times 5 is 45 over 2 plus 3. 1 cubed is 1, 1 squared is 1, so that's 5 halves plus 1. And there's an awful lot of nasty computation here. So I'll cut to the chase and tell you that that's 92 thirds. So that's how we use the fundamental theorem of calculus to evaluate that function. We find the antiderivative, evaluate at the endpoints, and subtract. So our next example is the integral from 1 to 9 of 5 over the square root of x. How is this going to work? Well, we want to use the power rule, so we've got to express the square root of x as a power. Square root of x is x to the 1/2 power, but it's downstairs. So if I have 5 over x to the 1/2, how could I write that? 5 times x to the negative 1/2 power. We can pull the constant out in front. So that's 5 times the integral from 1 to 9 of x to the negative 1/2 dx. At this point, we can use the power rule. The integral of x to the n is x to the n plus 1 over n plus 1. So kick this exponent up by 1. Negative 1/2 plus 1 is positive 1/2. So x to the positive 1/2 over n plus 1 over positive 1/2. But we're evaluating this as x goes from 1 to 9. Now 5 divided by 1/2 is 10. And x to the 1/2 is really the square root of x. So first 10 times x to the 1/2 evaluated as x goes from 1 to 9. 10 times the square root of x evaluated as x goes from 1 to 9. So here's our antiderivative, our capital F of x, 10 square root of x. Evaluated at 9 minus evaluated at 1. That will be the answer to this original integral. So you'll notice we have 10 times the square root of 9 minus 10 times the square root of 1, which will give us 10 times 3 minus 10 times 1, 30 minus 10, or 20. Our next question is the integral from 0 to 4 of e to the x dx. And we have to remember that the antiderivative of e to the x will be e to the x. Why is that? Because the derivative of e to the x is e to the x. So going backwards, the antiderivative of e to the x is e to the x. So little f of x is e to the x, big F of x is e to the x. So we're going to evaluate big F of x from 0 to 4. And we write it this way. There's our function big F of x, evaluated as x goes from 0 to 4. There will be e to the 4th, plugging that in, minus e to the 0. E to the 4 is a large number. E to the 0 is just 1, so our answer we'll write as e to the 4th minus 1. That's an exact answer. But again, it requires us to remember that the derivative of e to the x is e to the x. So the antiderivative of e to the x is e to the x. Our next question is the integral from 0 to pi over 4 of secant squared x dx. And our first strategy is to look for that antiderivative. Come up with a function whose derivative is secant squared x. The only way you can do that is if you memorize the derivatives of the trig functions. Derivative of sine is cosine, derivative of cosine is minus sine. Derivative of tangent is secant squared. Derivative of tan x is secant squared x. So the antiderivative of secant squared x will be tangent x, based on this fact. So going backwards, if the derivative of tan is secant squared, the antiderivative of secant squared is tangent. So we're going to evaluate the antiderivative from 0 to pi over 4 tangent of x as x goes from 0 to pi over 4, which will be tangent of pi over 4 minus tangent of 0. And then we need to know our trigonometry. Tangent of pi over 4 is 1, tangent of 0 is 0, 1 minus 0, so that our answer to that question is 0. And I think I have one more example to look at. Integral from 1 to 2 of 3x squared plus 5 times the cube root of x plus 7 over x dx. Now how do we want to proceed here? The first thing I did was to recognize the integral of the sum as the sum of the integrals. So I rewrote this as the integral from 1 to 2 of 3x squared dx plus the integral from 1 to 2 of 5 cube root x dx plus the integral from 1 to 2 of 7 over x dx. The derivative of the sum is the sum of the derivatives. The integral of the sum is the sum of the integrals. One of our favorite facts in calculus. Now I can also pull out constants. So 3 can come out in front, 5 can come out in front, 7 can come in front. So again, another reminder of some concepts from basic calculus. And notice I rewrote cube root of x is x to the 1/3. Now I can get the antiderivative of x squared by using the power rule. X to the n plus 1 over n plus 1. X to the 3rd over 3. I can get the antiderivative of this also by the power rule. 1/3 plus 1, 4/3. X to the 4/3 over 4/3. But the antiderivative of 1 over x is going to be one that you're going to have to memorize. The derivative of the natural log of x is 1 over x. So the antiderivative of 1 over x is the natural log of the absolute value of x. So reminding you of that. Our next line here, we have 3 times x cubed over 3 as x goes from 1 to 2. There's 5 1/3 plus 1, x to the 4/3 over 4/3 as x goes from 1 to 2. And as I mentioned, the integral of 1 over x is log x, natural log of absolute value of x, as x goes from 1 to 2. Now, we'd like to simplify this. You'll notice the 3 divided by 3 here divides out. 5 divided by 4/3, if you're going to divide, invert and multiply, that's 5 times 3/4, 15/4. So it'll be easier for us to work on. And then we have our 7 log x as x goes from 1 to 2. So again, 3's cancels, 15/4, 7 log x. The next thing I've got to do is I have to plug these values in. So it will be 2 cubed minus 1 cubed here. 15/4, 2 to the 4/3 minus 1 to the 4/3. 7 log 2 minus 7 log 1. So you'll see how that works. First piece, 2 cubed minus 1 cubed. Second piece, 15/4, 2 to the 4/3 minus 1 to the 4/3. Last piece, 7 times natural log 2 minus natural log 1. And now it becomes a game in arithmetic. 2 cubed is 8, 1 cubed is 1, 8 minus 1, that'll give me 7. 15/4, cube root is 16 minus 1. And then we have what? Then we have 7 times log 2 because natural log of 1 is 0. E to the 0 is 1. And all I've got to do is sort of simplify the arithmetic here. 8 minus 1 is, of course, 7. Cube root of 16 is cube root of 8 times cube root of 2. And cube root of 8 is something that we know, plus 7 log 2 here. Cube root of 8 is 2. So we'll get 7 plus 15/4 times 2 cube root of 2 minus 1 plus 7 log 2. This fraction, I guess you could say it's 30 cube root of 2 over 4 minus 15/4. But of course, 30 over 4 would reduce to what? Would reduce to 15/2. So our final answer would be 7 plus 15/2 cube root of 2 minus 15/4 plus 7 log 2, and then 7 minus 15 fourths can also be simplified. 28 minus 15, what do we get? 13 fourths. So indeed, 13 fourths plus 15 over 2, cube root of 2, plus 7 log 2. And that will conclude this lesson.